Hello there, this is Professor Eckhouse, and I am going to talk today about problem solving, which basically means word problems. So this is what we're going to cover today. I'm not going to read it to you. You can pause and read it yourself. And then also today I recommend that you start a formula and equations sheet. So in your notebook, just have one page where you just start collecting any formulas and equations and things like that all in one place, so you don't have to go looking for them. All right, so the first topic is translating words into algebra. So here's an example of a problem like this. I am not going to talk about these because every single one has a video example with it. A couple of videos are the same, but many of them are different. So just keep looking at the different problems, and they have some different videos. So lots of examples there for you. So don't forget about the textbook. Also, don't forget about the textbook. The textbook has a bunch of things for you to work on in there too, and example videos and things like that. All right, so my first example for you is a problem that involves cell phone plans. So we've got two different cell phone companies and they offer different packages. So company A charges a monthly service fee of $32 and $0.04 dollars per minute. They're 4 cents a minute. That's how you would write it in dollars. 4 cents a minute talk time. The other company charges a base fee of $45. That's a monthly service fee, plus 3 cents per minute talk time. So think about which one of these is the rate of change and which one of these is going to be, your starting point or your base price. All right, so the first thing we want to do is determine your unknown. So X is going to be your minutes talked. Okay, so I would usually use things like T or M, T for time, M for minutes, but because this is similar to a problem in the homework and they want you to use X, I'm going to use X. All right, so the model for company A, so that's the yellow one, can be written as, so think about your rate of change. Your rate of change is 0.04. And that's going to be times the minutes talked. So you talk for 1 minute, it's 4 cents. 2 minutes, it's 8 cents. 3 minutes, and so on, right? So that's going to determine your price from the number of minutes talked. Plus 32 is going to be your base price. All right, so company B is going to be similar. So this one is 0.03x. Don't forget your x. If you forget your x, it's not an equation. It's just a bunch of numbers. Plus 45. All right, so that's the base price for company B, service fee. All right, so now the next question is, if the average number of minutes used each month is 1,332, how much does this cost for each company? Well, what is 1,332? What is this number right here? I'm going to use a different color. What is this number in our equation? Well, that is X. That's X. All right, so all you have to do is plug it in. So we're going to have A equals 0.04 times our 1,332, 1,332, plus 32. And when you work that out on your calculator, you should get, and this is in dollars, 85.28. Because it's a cost, right? So you want to put it in dollars and you want to go to the cents. I see so many people go to like 3 digits or 4 digits with money. You always want to go to the pennies, right? So that's the second decimal place. All right, company B would be 0.03 times our X, which is 1,332, plus the base price of $45. So I'm just using these equations that we made up here. All right, and that, when I plug it in the calculator, is going to give me I would recommend pausing and plugging these in and making sure you're getting the same numbers so you know that you're plugging it in your calculator correctly. All right, so that's the final amount on those. So which one's a better deal? Well, at this talk time, it's $84.96. All right, so company B would be a better deal if you talk that many minutes. Okay, so let's talk about distance, rate, and time. So the formula is D equals RT, where D is the distance, and it can be in any measurement of distance. R is called the rate, in other words, the speed or the velocity, and T is the time. in any measurement. So the rate units are going to depend on the units of distance and time. All right, so for this next example, I highly recommend on word problems in any class, math, physics, chemistry, whatever, that you write down all of the variables in the equation you're going to be using, and then go back up to the problem, find them all, and put them in the right place. That will keep you from making mistakes. All right, the rate is 69 miles per hour, so that's 69 miles per hour. And it went for 276 miles, that's distance, so 276 miles. And the time is our question mark. So here's what I'm going to do, and you don't have to do this, but I really recommend that you start because we have some pretty complicated formulas in science and math sometimes, and so it's easier often to rearrange the formula instead of rearranging it after you plug your numbers in. So what I want to do is I want to solve for t because that's what I'm looking for. So I'm going to divide both sides by the r, and I get t equals, the r cancels, d over r. T equals d over r. So now all I have to do is plug in 276 miles and 69 miles per hour, and I don't have any rearrangement to do with all those numbers and units and stuff like that because I've already rearranged it. And I'm going to get 4 hours. 4 hours. So he's traveling for 4 hours. All right, so area and perimeter is the next topic. So when we have a rectangle, we'll call this one the length and this one the width. And the area then is going to be length times width. And the perimeter is going to be, well, if this is L and this is W also, hopefully you see that the perimeter would be L plus W plus L plus W, which is 2 L's plus 2 W's. All right, so that's a couple of formulas that you need to have in your head or in your notes. So how would you set up a problem that said the length is blank longer than the width? All right, so we said that this was the length and this was the width. But let's just say that the length is maybe 2 inches longer than the width, 2 feet, whatever it is. So then we would say that the length is 2 plus W. And now for the area or the perimeter, you could just plug in this instead of L and solve the problem. Okay, so now let's just say, you know, it doesn't always have to be 2. I don't want to confuse anybody, but what if this is 3 and it was shorter? Well, if it was shorter, then you would say W minus 3 if it was shorter. Okay, so that's how you set those up. So watch the video linked in each homework problem to better understand how to do these. All right, so volume, there's a formula for that. So we've got length and we've got width, and now we've also got height. So the volume is going to be the length times the width times the height, which we usually just write LWH, which you can write in any order you want. And the same is true for the last problem. If it says the height is twice the length or something like that, you would say, if I said the height was twice the length, you would say 2L. And then you could plug 2L into the equation. Okay? All right. So isolating variables and formulas. This is another thing you'll be asked to do. So we are being asked to express the formula for surface area of a cylinder in terms of H. So this is the formula for the surface area of a cylinder, like a can. It would be the surface area of the whole thing, including the top and the bottom. But we've got to do it in terms of H. Okay, so here's my H. So we need to isolate H. I want to send everything else to the other side. How am I going to do that? Well, the first thing you want to do is deal with the pluses and minuses. So you're going to say minus 2 pi r squared minus 2 pi r squared. And it's going to cancel here. And I get s minus 2 pi r squared equals, what do I have left on the right? Well, I've got 2 pi r times h. I'm going to put parentheses around the 2 pi r, which I can do because it's all just multiplied. I can put parentheses anywhere I want, do it in any order. So now you can see that if I want the h by itself, I'm going to divide by what? 2 pi r. 2 pi r, both sides. And I get as my final answer that h equals this thing over here, s minus 2 pi r squared over 2 pi r. Does anything cancel? No, nothing cancels because we've got a minus right here. You can't cancel across a minus. All right, so that's the final answer. So this is our answer. Okay, moving on to example 4. Given the formula for surface area of a rectangular prism, a box, solve for W. All right, so there are two W's here, so we want to get them on one side, and then we want to factor them out. All right, so subtract 2LH on both sides. And I'm going to have S minus 2LH equals 2WH plus 2WL. All right, so now I'm going to shift this over just a little bit. I've got S minus 2LH. I would like to factor out the W because that's what I'm solving for. And I had to look over and double check. That's what I'm solving for. All right, and so I want to factor that out. So I'm going to have W times 2H. So what's left when I take when I divide a W out of each of those? What's left? Plus 2L. All right, so now how am I going to get the W by itself? Divide both sides by 2H plus 2L. 2H plus 2L. They cancel here. Because they are factors, they're multiplied, we can cancel them out. All right, so we've got W equals S minus 2LH over 2H plus 2L. It's a mess, but it works. All right, next one. Try pausing and solve for B. All right, so I'm going to write this a little bit bigger. So I've got A equals 1/2 times B times H. Okay, so remember when they're next to each other like that, it means they're all multiplied. So I want to get the B alone. So I'm going to multiply both sides by 2 over 1, or just 2. And that means that this is going to go away. All right, so now I've got 2A equals BH. Now I still want the B to be by itself, so what am I going to do? I'm going to divide both sides by the H. And I get that B equals 2A over B. Almost made a mistake there. No, not over B, over H. I got in a hurry, sorry. B equals 2A over H. All right, I'm going to go back and make sure I got that one right. I'm looking at my notes real quick. Yes, I did. Okay. All right, so let's move on and talk about the last topic, which is temperature, Fahrenheit and Celsius. First, let's make sense of your answer. So take a look at this little table I've got here. What is the freezing point in Fahrenheit? Well, that is 32 degrees Fahrenheit. And what is the boiling point? That's 212. How random is that? Especially when you look at Celsius, which the freezing point, they made it 0, and the boiling point, they made it 100. So a little bit, I don't know, makes more sense. But here's our formula for converting from Fahrenheit to Celsius. So we're being asked to convert 80 degrees Fahrenheit. So how hot is that? Just kind of think about how hot that is. And what's that going to look like in Celsius? Try to look at this little chart we made and see if kind of about where you think that would be before we start. All right, so we've got C equals 5/9, and we want to put 80 in where the Fahrenheit is, minus 32. All right, so this is going to give me 5/9 times 48. And when I put that in my calculator, I get 26.66666 forever. And so I'm just going to round it to 26.7. We usually go to one more decimal place, but no more than that. That wouldn't make sense really, than our original number. All right, so this degrees Celsius is our final answer. All right, so sounds cold to us, but it's not, it's 80. All right, let's solve the formula for degrees Fahrenheit. So pause the video and see if you can solve this formula for degrees Fahrenheit. All right, so we need to isolate the F. So the first thing we need to do is get rid of this. I'm just going to go like this and scoot this over just a little bit so I have some room to write. All right, so I want to get rid of this 5/9, so I want to multiply both sides by the reciprocal, 9/5. And that's going to cancel the 5 and the 9. That's why I did it. All right, so I've got 9/5 C equals F minus 32. And now all I have to do is add 32. So I get F equals 9/5 C plus 32. Okay, so there's our formula for Fahrenheit. So now we're being asked to convert degrees Celsius to degrees Fahrenheit, and we can do that with our new formula that we just created. So we've got F equals 9/5 times 10 plus 32. And when I put that in my calculator, I get 50 degrees. Make sure you get it too, that you know how to do this in your calculator properly. All right, that was my last example. Thank you for watching.